How do we know when a function is exponential or not? First, let's talk about exponential expression. What does it look like? So exponential expression has the form a to the power b. What's what here? Well, this guy a, this is called the base of the exponential expression. And this guy here, that's exponent or power. When it comes to exponential functions, you're looking for the unknown to be in the power or in the exponent, not at the base. Number one. Number two, the base should be a positive number, cannot be negative, and it also cannot be 1. Now, I want you to compare two functions. One of them is x squared, and the other one is 2 to the power x. Again, remember, exponential functions are the ones where x is in the power, not in the base. Let's say that I decided to pay you let's say 2 cents for coming to the first class, and then I'm going to double it every time you come. What is the difference? If I double it, that's exponential. Whereas if I square, let's say you come 10 days, square, that's 100 cents I'm going to have to pay you. Let's say you came 25 times. I will have to pay you 625 cents. In other words, $6.25. That is if it's like a square. But what if it's exponential? Let's look at how much money I would have to pay you. Well, it looks like, oh my God, 33,554 and 432 cents, which is approximately $335,544. So which one is growing faster? Obviously exponential. Now, looking at these examples, which are exponentials, and if they're not, why not? Let's look at the first one. So exponential expression x to the power n. The unknown is in the base, right? Right here. This is not good, okay? This is definitely not exponential. Now, 2/3 to the power x is automatically exponential because we see the unknown is in the power. And also this guy right here is a positive number. So yes, that is exponential. Now, why is negative 3 to the power x not exponential? Well, that's because the negative 3 does not satisfy the property that the base should be a positive number not equal to 1. That's why this is not good, okay? So this is not exponential. Now, when you look at 9 to the power negative x, this is where you can get confused, and you may think, well, maybe that's not exponential because there's a negative. But remember, the negative cannot be in the base. What if the negative is in the power? Is that still exponential? Well, let me explain. Actually, by definition of a negative power, the way it works is you don't pull the negative outside of the exponential expression. Actually, this becomes 1 over. The negative power, if you want to get rid of it, you move the expression to the bottom and negative goes away. Now, you may say to yourself, okay, how is that exponential? How is that some kind of number raised to the power x? But think this way. 1 is actually 1 to the power x, right? Because 1 multiplied by how many times doesn't matter, will still give you 1. Okay? And using properties of exponents, we can now say that if 1 is raised to the power x, and then that's divided by 9 raised to the power x, that's the same thing as 1 over 9 raised to the power x. And this does satisfy the properties of exponential function.